Hi all, so today we're learning Year 10, 5.3, Properties of Geometrical Figures, Deductive Reasoning using Parallel Lines. So we already know geometrical facts concerning angles. We can find the sizes of unknown sides and angles, and when we do so, we need to give a reason for each statement that you make when showing how to find the unknown side or the angle. We use the correct terminology when we do this, and the reasons that we use are usually abbreviated, but we need to take care not to abbreviate them to such an extent that the meaning is lost. We also need to remember that problems often can be solved in more than one way, and that usually one method is more efficient than another. So what we have here are some terms, and these terms are useful when we are writing our reasons and abbreviating them. So I want you guys to make sure that you come back to these terms throughout the entire topic of properties of geometrical figures to ensure that you are using these correctly when you are writing your reasonings for finding angles and sides. What we're going to do before we start looking at parallel lines is that we need to make sure that we remember our angle properties and mainly our adjacent angle properties. So adjacent angles have a common vertex or point, and in this case over here it is A. In our example, they have a common arm, and in our case it is the arm AC, and they lie on opposite sides of this common arm. So we have angle 62 and angle 28 on either sides of our arm AC. So angles are complementary if two adjacent angles add to 90. So this means that complementary angles add to 90 degrees. Then together they form a right angle where 90 degrees is a right angle, and the complementary angles are adjacent to each other. So angle BAD is a right angle. So in our example over here, we have 28 degrees plus 62 degrees equals 90 degrees. So that means that this angle up here, this beautiful angle here, is going to be an adjacent complementary angle. Angles are supplementary if two adjacent angles, add to 180 degrees. Then together they form a straight angle or a straight line. The supplementary angles are adjacent, so ABC is a straight line. So in our example over here, we have that our two angles of 68 degrees and 112 degrees add together to equal 180. That means that we have angle ABD plus angle angle DBC equal 180 degrees. Therefore, angle ABD and angle DBC are supplementary. In adjacent angles, we also have that if a series of adjacent angles completes a revolution, so that means that it goes all the way around, the angles must add to 360 degrees. So a revolution adds to 360 degrees. So we say that the angle sum at that point is 360 degrees. So say we had 50 degrees plus 160 degrees plus 80 degrees plus 70 degrees. Well, this adds to 360 degrees. So that means that we have angles at the point that add to 360. Moving on to vertically opposite angles. When we talk about vertically opposite angles, we are talking about when two straight lines cross, we have two pairs of vertically opposite angles are formed. And these vertically opposite angles are equal. So in our case, we have this angle here and this angle here, and they are equal to one another. And we also have our dot here and our dot here, which are equal to one another. If we were to say that our dot over here equals 70 degrees, that would mean that the angle vertically opposite it also equals 70 degrees. And vertically opposite angles make this X shape. So when we go over our angles, we make an X. So whenever you see this X shape, you know that the angles opposite each other are equal to each other. So we have vertically opposite angles are equal. Moving on to parallel lines. So what we know about parallel lines is that they are two straight lines that never meet or never touch. They are always the same distance apart from one another. And we have this transversal, which is a line that cuts the two parallel lines at a point. So we have three types of reasonings for parallel lines. The first one is corresponding angles. So if a transversal cuts two parallel lines, then corresponding angles are formed. And corresponding angles are equal, and they create an F shape. So how we show this is if we go around our first angle over here of 110 and our second angle that we're given of 110, we make an F shape. Now this F shape we can see by rotating our page or rotating our screen, and we'll eventually see the F, but in this case it's an upside down flipped F. If I was to go around my 70 degrees and my other angle is 70 degrees, we have an upside down F again, making an F shape, meaning these two angles are equal and that they're corresponding angles. For 110, if we go around this 110 and this angle of 110, we make our F shape. That means that these two angles are corresponding angles and they are equal. And finally, if we go around our angle of 70 and our other angle of 70 degrees, we see that we make our backwards F shape, so we have corresponding angles are equal. We also have alternate angles when we are talking about parallel lines. Now, alternate angles is when if a transversal cuts two parallel lines, then alternate angles are formed. And we have that alternate angles are equal and they make a Z shape. So that means when we go around our angles, so around our 70 degrees, it makes this Z shape. So these two angles are equal to each other and they are alternate. And if we go around our 100 degrees here and around our 100 degrees here, we have that our two angles are equal to each other and they are alternate. Finally, we have co-interior angles with parallel lines. This is our final one. So if a transversal cuts two parallel lines, then the co-interior angles are formed. Co-interior angles are supplementary, which means they add to 180 degrees and they make a C shape. So if I was to go around my first angle, which in this case is a dot, and my second angle, which is an X, it makes this C shape. And we just have that our dot plus our X equals 180. And finally, if I go around my X and I go around my dot, we have that my dot plus my X equals 180 degrees in both cases. So far we have looked at what the terminology and abbreviations are for all our terms, what adjacent angles are, complementary, supplementary, and what a revolution adding to 360 degrees is. We've also looked at vertically opposite angles, corresponding angles, alternate angles, and co-interior angles. We're going to move on to some examples now, and in our examples we are going to look at how to find the size of angles, okay, using parallel lines. For example 1, our question says EH is parallel to GH. Oops, that is meant to be EF. Apologies. EF is parallel to GH. So we want to find the size of angle C at GCD. So we are trying to find angle GCD, which is this angle here. Okay, we're trying to find this angle here. So, and what we know is we know that angle ABE equals 76 degrees. So what we're going to do is we already know that angle ABE equals 76 degrees. So we are going to find out if we can see anywhere else that equals 76 degrees on our diagram. So I'm just going to zoom into our diagram for a second. So from what we know about our adjacent angles, our complementary, supplementary, vertically opposite, corresponding, alternate and co-interior is that if this is 76 degrees here, that if we go across here, we have that angle EBC is 76 degrees because of vertically opposite. So what we're going to do is our first line of reasoning is going to be that angle, I'm going to do this in a different colour, that angle ABE is what the angle that we've been given, equals angle EBC, which equals our degrees of 76 degrees, and our reason for this is going to be vertically opposite angles. So we can just write vert op angles, and that stands for vertically opposite angles. So now that we know that this angle EBC is 76 degrees, can we see either some corresponding, co-interior or alternate angles? Yes, we can see corresponding angles. If we were to go around the angle that we now know and the angle that we have been given, we see our backwards F shape. That means that angle EBC is equal to our angle GCD, which equals 76 degrees, and our reason is corresponding angles. So we go cora angles, and we have to show that this is because of parallel lines. So we say EF is parallel to GH, and that is that question done. So what we did to recap that question is we tried to use what we had been given. What we had been given was our 76 degrees to find different angles. There's multiple ways to do this, but this is just a way that I have seen how to do it. Example 2, we have that AB is parallel to CD, and we want to find the size of angle CGH. Now CGH is here. We want to find that angle. So what we're going to do is that we have been given that AFE is equal to 81 degrees. So we're going to use that in some way. Now, if we were to go around angle AFE, we want to see if we can do some vertically opposite, corresponding, alternate, or co-interior angles. The best one that I can see to do is to go around this angle here and make a corresponding angle, meaning that CGF is going to be equal to 81 degrees. So I'm going to write that on my diagram, and we're going to write our reasoning down for this. So we're going to say that angle AFE equals angle CGF, which equals 81 degrees. And our reason for this is corresponding, oh, that turned out horrible, sorry, is corresponding angles, and we need to say that it's because of parallel lines, where AB is parallel to CD. So now that we know the angle CGF, we can use what we know to solve what angle CGH equals. So if I was to go along our transversal, we can see that it's a straight line. And because it's a straight line, our CG, our angle FCG, and angle CGH are going to add to 180 degrees. So these are adjacent supplementary angles. So in order to find our angle that we're trying to find, which is angle CGH, I'm going to write 180 degrees minus our angle sorry about my pen, guys. CGF, which equals 180 degrees minus our 81 degrees, and 180 minus 81 degrees equals 99 degrees. And our reasoning for this is how we find angle CGH is because of adjacent supplementary angles. So that means that our straight angle of a straight line adds to 180 degrees. So now we have found our angle CGH to be equal to 99 degrees. And that is that problem solved. And we have given reasons. Moving on to example 3, we have that EF is parallel to GH, and we want to find the size of X and give reasons. So if I was to highlight where X is, our angle X, and I'm going to state this, is X equals angle GCJ. So there's a few things that we're going to have to do here in order to get close to there. And what I want to do is I want to write down everything I know over here, or even underneath my diagram, as it's just going to help me out in my reasonings. So something that we do know is that angle FBC equals 60 degrees. And we can see that there. And we also have this 90 degrees here. This 90 degrees here is saying that angle BCJ is equal to 90 degrees. So we're going to use these two bits of information that we have been given in order to solve our problem. So the first thing I'm going to do is I'm going to go around angle X, which I've done, which is my CGJ. And then I'm also going to have a look at my angle F. Oh, I'm not going to do it in that color, sorry. My angle FBC. So if I go around my angle FBC, I can sort of see that I can get next to my X angle by using angle BCG, which makes our Z angle, which makes an alternate. So that means that angle FBC is going to equal my angle BCG, which equals 60 degrees. And my reasoning behind this is because of alternate angles on parallel lines. So we write EF is parallel to GH. So now that we know that, I'm just going to take the information off the diagram to make it a little bit clearer. In order to find X, we know that BCJ equals 90 degrees. And we have also just found out that BCG is 60 degrees. So that means in order to find X, we have to go angle BCJ minus angle BCG will give us X. So our X angle will equal angle BCJ minus angle BCG, where angle BCJ is 90 degrees and angle BCG is 60 degrees. So then when we calculate what 90 minus 60 is, we get X equals 30 degrees. And our reasoning for this is because we have a right angle, it is adjacent complementary, so we just do comp, angles. And we have solved our question. Students in my 10 Maths 1 class, you would now complete exercise 301A from our signpost textbook. And we're doing question 1 to question 3 all.